Let's read this so we get a sense of what's happening. It says this: the converse of the Pythagorean theorem is also a true statement. Now, here's what the Pythagorean theorem says. Let me draw a picture here. We will have a right triangle, and if that base is A, that side is A, this is B, this is C. Pythagorean theorem says that A squared plus B squared equals C squared. So if this is a right triangle, then this is true. Now the converse is just the opposite. It says, if this is true, then you have a right triangle. And that's what this says here. This says, if the sum of the squares of the lengths of two sides, so I'm taking the sum of the squares of the lengths of two sides, is equal to, right, okay, is equal to the square of the length of the third side, the square of the length of the third side, all right, then the triangle is a right triangle. All right, so that's the converse. Now use the distance formula and the Pythagorean theorem to determine whether the set of points could be the vertices of a right triangle. And that's what this says here. Let's read it over. I'm up here at the top. If the sum of the squares, all right, look at our formula here. Here's the sum of the squares. I'll go back up to read it. If the sum of the squares of the lengths of two sides, so here's the sum of the squares of the lengths of two sides, back up to the read, is equal to the length of the square of the length of the third side. There's the square of the length, C, of the third side. So it says, if the sum of these squares of these two sides is equal to the square of the third side, then you have a right triangle. That's the converse. So I'm going to graph these points to see if it will even resemble a right triangle. So how about this? Here's 1 point, second point, third point. So 8, 2. So to the right 8, up 2. There we go. And then the second point is 0, 5. So no horizontal, start at the origin, no horizontal movement, but up 5. Right there. And then the third point is negative 6, negative 6. So to the left 6, down 6. To the left 6, down 6. I think it's right here. Okay, so if I connect those, well, sort of. All right, it looks like it could be a right triangle, but I don't know for sure unless we can verify that theorem. So here's what I have to do. I have to find this distance, and this distance. All right, now this is point A. See if I can get it to right. That's A, this is B, and this is C. So let's find the distance between A and B first. So let's see, I'm going to write the distance. Here's the distance formula. x2 minus x1 squared, right? Second x minus first x squared plus second y minus first y squared. Now, let's do this. I'm just going to label it. This is a little subscript, distance between A and B. So this is going to be the square root of, okay, now look at A and B. Here's A and B. Take the second x minus the first x. That's going to be 0 minus 8. So let's write that one. 0 minus 8 squared plus, now the difference of the y's. Second y minus first y, 5 minus 2 squared. All right, so this is going to give us the square root of, what do we get here? Negative 8 squared plus 3 squared. This is going to be the square root of 64 plus 9. That's the square root of 73. All right, so that's the distance between A and B. I'll circle it so I can find it later. Now let's get the distance. All right, so what I just found here was this. I found that distance right there. Okay, in fact, why don't we do this? This will be the square root of 73. Now, why don't we find BC? All right, so the distance now between B and C. All right, so the distance between B and C. Okay, here's our formula that we're going to use right here. So this is going to be the second x minus the first x now. And B and C, the second x is negative 6. The first x is 0. So it's going to be second minus first. So it's going to be negative 6 minus 0 squared plus, now the second y, right? Second y minus first y. So the second y is negative 6 minus the first y, which is 5. So this is going to be negative 6 minus 5 squared. This is going to be, now negative 6 minus 0 is just negative 6 squared plus negative 6 minus 5. I'm down 6. I lose 5 more. I'm down 11 squared. Negative 6 squared. Negative 6 times negative 6 is 36 plus, now negative 11 times negative 11 is 121. All right, so this turns out to be the square root of, what do we get here? 157. All right, so that's the distance between B and C. All right, so let me note it over here. B and C, this is going to be the square root of 157. Now let's get this last one. Let's get this distance here between A and C. All right, so this will be the distance between A and C. So this is going to be the square root of, all right, here's our formula, second x minus first x squared. So A and C, be careful, here's a long jump. A and C. The second x is negative 6. The first x is 8. So this is going to be second x minus first x, negative 6 minus 8 squared, plus, well, what is this? This is the y's now. Second y minus the first y. So negative 6 minus 2. So this one will be negative 6 minus 2 squared. This will be negative 14 squared plus negative 8 squared. So this is going to be square root of 14 squared is 196 plus 64. That's going to turn out to be the square root of 260. All right, so that's the distance between A and B. No, it's not. It's A and C. So I'll write that up there. This is the square root of 260. Now here's what I'm going to do. I'm just going to rewrite these numbers over here. So the distance between A and B is that square root of 73. The distance between B and C is that square root of 157. And then the distance between A and C is that square root of 260. Now in a right triangle, the longest side is going to be the hypotenuse. So if this triangle here, if this triangle that we're dealing with here is going to be a right triangle, this longest side here would have to be the hypotenuse. That's the only way this could work. This is the longest side, right? Square root of 260 is bigger than square root of 157, which is bigger than square root of 73. So the only way this could work is this would have to be the hypotenuse. So this would have to be C. So if I label those here, this would have to be C, and then maybe I could make that A and this B. All right, so then I would have this, A squared plus B squared equals C squared. Let's see if it works. All right, so I got some room here. So A is square root of 73, B is square root of 157, C is square root of 260. All right, so this is the A, this is the B, and this is the C. And here's the Pythagorean theorem. So A squared is going to be square root of 73 squared plus B squared, which is 157 squared. Is that equal to square root of 260 squared? Well, when you square a square root, we're lucky here. When you square a square root, the radical just comes off. So we're looking at 73 plus the square root of the square is 157. Is that equal to square root of the square? If you square root 260 and then square it, you're back to 260. Well, 73 plus 157 is only 230. That is not equal to 260. So this is not a right triangle.